Okay, so for all participants, please be ready because the event will start about around 1 minute again. Thank you. Good afternoon, Miss Chantala. How are you today, Miss?
Very well, thank you. How about you?
Thank you, I'm very well too. Okay, so excited to have you here. Okay,
Me too. Glad to be here.
thank you so much for joining us, Miss. Okay, so it's already 2 o'clock. Okay, please wait. Okay, so good afternoon, everyone. Welcome to the 2026 International Youth Talk. My name is Chacha, and I will be the master of ceremony for today's event. And today we are excited to have amazing students from various schools, and we will be discussing about how practical workshops help me understand engineering. But before we jump into the next sessions, I would like to remind all participants to use our virtual background that can be downloaded and also provided on the chat box, and also open your camera to make our event more interactive. Okay, next I will share about explain about our event introductions. So the International Youth Talk is a dynamic online platform dedicated to empowering the global youth community to take an active role in shaping a sustainable future. Organized by Simeo TED and co-hosted by the Southeast Asia Youth Sustainable Development Foundations, or PASITA. And this initiative serves as a flagship program under the China ASEAN Technical Education Cooperation. Through collaborative efforts, the program fosters meaningful dialogue, cross-cultural understanding, and innovative solutions among young leaders worldwide, inspiring them to contribute to global sustainability goals. Okay, so next for the flow of the events. So, for the first session is presenter school. So, I will introduce all of the presenter schools. And then for the second session is opening remark. And then for the third session is presentation session, the first presentation session, and followed by the Q&A sessions. And then for the next agenda is presentation session 2 and followed by the Q&A session. So the presentation session will be separated into 2 sessions. And for our last agenda is a group photo where we will have a group photo later. Okay, next. Okay, so for the presenter schools for today's event, we will have 4 schools, 4 amazing schools. So for the first schools is from Liskinsky Industrial and Transport College, Russia. And then for the second school is from Polytechnic Sultan Haji Ahmad Shah, Malaysia. And then for the third school is from Capiz State University, the Philippines, and then for the last school from Institut Teknologi Nasional Bandung or ITENAS Indonesia. Wow. It's very cool. Okay, but before we jump into our main sessions, we will have opening remark first from Miss Cheng Chantola. She is the head of administrations, finance, and planning division Simioted. Okay, so for Miss Cheng Chantola, the time and screen is yours.
Very good afternoon, everyone. So nice to meet you online. So I would like to, to say thank you for allowing me to be here, to open the remark. So on behalf of Simioted, I would like to warmly welcome esteemed participants, young innovators, learners, and presenters. It is a pleasure to be here with you today to explore a topic that is not only essential to the future of vocational education, but also exciting and inspiring. How practical workshop help me understand engineering. The engineering can sometimes seem difficult when it is only explained through theory, formula, and textbooks. However, practical workshop give you the chance to see and experience how those theory work in real life. Engineering is not just about memorizing formula or reading textbook. It is about applying knowledge to solve the real-world problems. While theory gives you the foundation, practical workshop bring that knowledge to life. So in workshop, everyone has the opportunity to learn by doing. We can see how machines operate, understand how systems are built, and experience how small adjustments can make a big difference. In hands-on learning, make complex concepts clearer and easier to remember. Practical workshop also encourage teamwork, creativity, and problem solving. They allow students to make mistakes, learn from them, and improve. This active learning process helps everyone gain confidence and develop real engineering skills. So in short, practical workshop transfer engineering from abstract idea into the real experiences that everyone can understand and appreciate. So last but not least, I wish you all the best and get a fruitful sharing, discussion, and learning. Thank you.
Okay, thank you so much, Miss Chantala, for having you here. Is such a pleasure. Thank you so much, Miss. Okay, next we move to our main sessions or main agenda, which is presentations from various schools. So the topic is how practical workshops help me understand engineering. And just to remind you all, for all the speakers, every presenter is suggested to explain topic from different perspective, and you will have around 10 minutes to present your presentations. But don't worry, and later I will also remind you when the time is running out. So okay, so for the first round or first sessions, we will have Liskinsky Industrial and Transport College Russia, and also from Polytechnic Sultan Haji Ahmad Shah Malaysia. Okay, so next I will trying to introduce all of the speakers from Liskinsky Industrial and Transport College Russia. Okay, so we will have Miss Anastasia Kulintsova, and then Miss Anastasia Nikiforova, and also Mr. Pavel Baranov. So, are you guys already here with us? Can you say hi?
Hi.
Okay, cool. Okay, maybe without any further ado, I will let you to share your screen, please.
Can you see?
Okay, it works very well. Yeah. Okay, so the time and screen is yours. Thank you so much.
Good afternoon. You can see the title of my report in the slide. So let me start. A CNC machine isn't just a piece of hardware, it's a part of digital chain. Without software and control system, it is just useless method. The entire process can be roughly divided into 3 layers. Here, engineers create a 3D model of the part in CAD. Then a technologist uses a CAM system to write the control program. close the machine based on the model. All data is stored in a PME system, a archive of all runs and programs. The brain of the machine in the CC controller, which executes the G code. MES is the main workshop system. It's inside the plane, assigns tasks to a machine, transfers programs, and monitors the process. SCADA is the dispatch control panel showing the status of all equipment. The ERP system is the master planner of the factory. It creates production and procurement plans and the assigns tasks to MES in the workshop. It all starts with a 3D model on CAD and machine program from CAD. Then an order page of the part appears in ERP. MES directs the task to an environment machine. The operator starts process and plan take progress in real time. After manufacturing, the operators record the result in the system. MES collects statistics and send a report to ERP to close the order. Key trends are the digital twin, the industrial Internet of Things, and predictive analytics. This makes production smarter and more reliable. The brain speed, high accuracy and stability, flexibility, process transparency, and as a result, not cutting, detect, and downtime. Implementation is expensive. Qualified personnel are required. Integration problems after arriving between systems from different vendors. Cybersecurity is also critical for science network connection. Machines can be found targeted or hacked. A modern CEC machine is just in one code. In a large system, CAM is the brain, MES is a workshop nervous system, and ERP is the enterprise with memory and logic. Together they create smart and competitive production. During my upcoming internship, I will have the opportunity to work with a CNC machines firsthand. I will learn how to set up simple tasks, like pre-writing G-code, and control the machine process under supervision. This experience will help me better understand how the digital system I described, like CAD, CAM, and MES, connect to real production equipment.
The specialty automation and mechanic in railway transport. Trained specialists therefore ensure the operation of control signaling, blocking, and communication system in railway transport. The curriculum includes the study of electronics, electrical engineering, microprocessor technology, as well as the specialized disciplines of the automation and diagnostic of railway transport system. The training combines theoretical classes with practical training, including internships at railway enterprises. Some of the responsibilities of specialists of the field of automation and telemechanic and railway transport, construction and operation of devices and systems for signaling, centralization and blocking, and railway automation and telemechanic. Maintenance, repair, installation, and commission of CB and JAD device and system. Identification and elimination of malfunction and damage to device units and equipment. Automation is a system that allows for the control of process without human intervention. Remote control is the field of remote information transmission for the control of mechanism. Improving train safety, optimizing traffic control process, reducing the human factor, efficient use of resource. Main components: signaling system, traffic lines, signs, traffic control system, centralized control system, track condition monitoring sensor and monitoring system, communication and telemetry. Radio communication, GSMR, examples of telemechanic system, telemechanization, remote control of switches and signals, track condition monitoring, using sensor to monitor the condition of rails and sleepers. Technological trends, implementation of artificial intelligence in control system, use of big data for process analysis and optimization, development of internet technologies to improve communication. In our class, we were preparing for practice and we were working on the last stands to repair and solve problems. Automation and telemetry play a key role in modern rail transport. The implementation contributes to improved safety, efficiency, and reliability.
Exploring how setback can drive innovation and personal development, understanding failure as an opportunity for learning and resilience, not just an obstacle. Mistakes are crucial for growth, providing opportunities to learn and improve skills. Embracing errors fosters resilience, creativity, and a deeper understanding of the subject. Analyze root causes and to identify key mistakes, embrace flexibility to overcome unexpected challenges, develop strategies to withstand future setback effectively, apply insights to improve future decision-making processes. Errors arise from ignoring the data's background and source. Valuable insights often hidden in other feedback are missed. Metrics can mislead if not considered with qualitative factors. Promptly recognizing mistakes helps in addressing them efficiently. Use tools like root cause analysis to understand error origins. Develop strategies to prevent recurrence of similar mistakes. Encourage team discussion to learn from errors constructively. Failure offers lessons that guide future success and growth. Analyze failures to pinpoint areas for skill and knowledge improvement. Use setbacks to develop perseverance and a growth-oriented mindset. Embrace errors to gain valuable insights and drive personal growth. Adjusting to setbacks strengthens your ability to handle challenges. Viewing failures as a step to success fosters resilience and innovation. Encourage viewing failures as stepping stones to success, fosters an environment where sharing failures is safe, incentivize innovative attempts even if unsuccessful, analyze failures to improve strategies and outcomes. Review our main accomplishments so far, identify key challenges and how we addressed them, outline our next and objectives. Thank you for attention.
Okay, thank you so much for Russian team. Oh my God, this is such a really great presentations. I saw that you guys have about like 3 different presentations, right? 3 different topics. That's really cool and like complementing each other. Okay, so I would like to share my screen first. Okay, once again, thank you so much for Miss Anastasia Kulinsova and also Miss Anastasia Nikiforova and also Mr. Pavel Baranov for your great presentations. Okay, so for the next sessions, we will have Mr. Abraham Adrian Jacob from Polytechnic Sultan Haji Ahmad Shah, Malaysia. But before the session start, I would like to remind all the participants, if you guys have any questions, you can just write down on the chat box. And don't forget to also put the name of the team member, okay? So that I could know which one you guys want to ask for. Is it for the Malaysia team or for the Russian team? Okay, next for Mr. Abraham, are you already here with us? Can you say hi with us?
Greetings, hi. Can you see me?
Yeah. Oh, wait.
All right.
I haven't seen.
Okay, can you see
Okay,
me?
yeah, I can see you and hear you clearly.
All right.
Okay.
All right. So,
Okay, so
I'm gonna
yeah, without any further
share
ado,
my screen.
and
All right.
screen is first. Okay, I will stop my screen first.
Okay, can you see my screen?
Yes, can you make it full screen? Yeah, it's really
All
cool.
right.
Okay, I can see it clearly.
All right. So today we'll be talking about how practical workshops help me understand engineering. So my title for my presentation is Hands-on, Minds-on, which deepens the understanding of engineering through workshop experience. All right. So this is a fun fact. Did you know that 83% of employers prefer graduates with hands-on skills gained through experiential learning, for example, internships, workshops, and real-world products compared with those who only have academic classroom knowledge. This suggests employers strongly favor candidates
Sorry,
with practical
Mr.
experience.
Abraham.
Sorry?
Yeah, sorry to interrupt you. Could you open your camera?
I think I did. Wait, hold on. Sorry. Hold on.
Okay, thank you so much. Yeah, so that we can see your face clearly. Okay,
All right.
thank you so
Now,
much. You can continue.
okay. Now can you see me?
Unfortunately, no, sir.
No? Okay, hold on.
Okay, take your time. It's okay. We still have many times.
All right. Can you see me now?
Yeah, I can see you clearly,
All right.
but your
Can you
screen
see?
is not presenting your presentation.
Okay. Can you see my screen now?
I can see your screen, but it's still
Alright.
on the Zoom, I guess. Yep, now I see. So when you switch to your presentations, your camera is off. I don't know why. Wait for a second. Oh, or maybe we can help you to share your screen. Is that okay?
All right. All right. Do I send it or how? How do I send it to you? Or do you have it?
Yeah, I already have your presentation. Wait a minute, okay?
All
Wait
right.
for a
All
second.
right. I'll stop sharing my screen.
Okay, I'll share my screen first. Okay, could you see my screen now?
All right. I can see. Yeah.
Wait, we'll make it full screen first. Ah, can you see it in full screen now?
No, not yet.
Not yet? Okay, wait. Maybe like this. Ah, this one, right?
All right. All right. Thank you.
Okay, you can just
Thank
say
you.
next, okay? I will help you. No
Okay.
problem.
Okay. Sure. Yeah. All right. Yeah. This is the slide. So I'll just read it one more time for you. So this is an interesting fact. Did you know that 83% of employers prefer graduates with hands-on skills gained through experiential learning, for example, internships, workshops, and real-world projects, compared with those who only have academic classroom knowledge? This suggests employers strongly favor candidates with practical experience when evaluating job applicants. So this particular statistics or information is not just applicable to Malaysia, but it's also applicable to other countries as well, not just in Southeast Asia, but also ASEAN and globally as well. All right, next slide. All right. So here is the gap between theory and practice, the difference when you just study theory but if you do study using labs and also workshops, this is the difficulties you'll face if you don't. So one of the common challenges is limited practical exposure. So what do I mean by that? When you study, for example, for me, I study civil engineering. So when we study civil engineering, some of the calculations we only use the calculations based on theory, and we don't actually apply them in real life because we are just doing the theory. But if you go and have workshops, you can actually understand the real life situation and the real world applications of concepts. So the second one is difficulty visualizing abstract concepts. So understanding theory becomes challenging. So would you trust a civil engineer who has only studied theory, or would you trust a civil engineer who has gone on site, who has gone on workshops, as well as done an internship with a site supervisor and so on? So this is where we need to see the differences between theory and practice. The third one will be lack of confidence in real world application. Now, this is very simple. For example, in civil engineering, we have contractors. Now, for the most basic example I can give you is when we look at renovations, house renovations, and so on. So when you look at house renovations, you can see that there's a certain conversation and communication between the client as well as the civil engineer or even the site supervisor. And at times, with lack of confidence in real world application, what happens is that the person doesn't really not able to communicate properly with the client, and therefore the results change. Maybe the wrong task or using the wrong bricks, wrong designs, and so on. All right, next slide. All right. So the definition of experiential and active learning. Experiential learning focuses on learning through direct experience and reflection, and active learning focuses on student engagement and participation during the learning process. All right, next slide. Okay, so this concept of hands-on, my-on is alignment with 21st century engineering competencies, problem solving, innovation, collaboration, and technical adaptability. Yeah, next slide. All right. Building skills and safety awareness. Now, these are the benefits of having workshop as well as laboratories and even on-site internships. So for one of it is the tool handling skills. Now, I know personally about this because I was in civil engineering laboratory, and we had to use a drill. So the drill using the drill is not easy. It requires some amount of experience and also strength. So practical workshops allow students to become familiar with different engineering tools and equipment. By using them in practice, students become confident and skilled in their use. This reduces the probability of errors in real-life engineering projects. So when I talk about errors, it's not just building something wrongly, but also safety problems like accidents and so on. Second thing is PP, proper use of personal protective equipment. So we use things such as safety helmets, gloves, and clothing. And students who go through workshops will understand the importance of these certain clothing. All right. So understanding workplace safety protocols. Practical workshops allow students to become familiar. Practical experience allows students to become familiar with safety procedures and safety guidelines. The fourth one is confidence in practical environments. Practical experience allows students to become confident in using their knowledge in real life situations. This is important in creating a culture that avoids accidents in engineering worksites or in engineering laboratories, and this allows for personal safety. Next slide. All right. Theory must be reinforced through real world practice. There are certain poor decision making skills that can happen, especially when you don't work on site. You do not know what materials to use, what type of grade of concrete, for example, in civil engineering, what grade to use, and so on. And also, I was talking about this earlier, communication gaps as well between the clients and also the civil engineers, and overconfidence in theory. So what I mean by this is when we do calculation, for example, in calculus or subjects like that, and even certain engineering calculations, there are many students who can ace the theory part of it and the calculation part of it. But when working in real life situation in on site, for example, civil engineers, they start having difficulty, and this is where workshops and laboratories actually help. All right. So next slide. All right. I'll just summarize this. So this is a difference between a theory-only civil engineer versus a civil engineer with hands-on or workshop experience. So you can see in the practical skills of how they use the materials and so on. You can also see in the problem solving. Like I said earlier, works well with textbook problems, struggles with unexpected real life situations. But on the other hand, a civil engineer with hands-on workshop experience can troubleshoot and adapt to real-world constraints. Now, another important part is the safety awareness part, whereby their knowledge is actually limited. And for example, the study of occupational safety and health subject, most students who only study this in theory will not appreciate and will not understand what is needed, what kind of safety is needed, and what kind of procedures we should follow. And lastly, of course, when it comes to career growth, the theory-only civil engineer is slower and needs mentoring and supervision. While then the civil engineer with hands-on workshop experience can take lead on practical on practical projects and field roles. All right, next. All right, so I'll just share my personal experience, which was my first semester in civil engineering. Now, these pictures are me and my group. So we were assigned to build a small wall, and so this is my first semester. All right, so in my first semester in college, we had a laboratory called the bricks laboratory, where we learned about the types of bricks, the different bonds for bricks when making a wall. For example, Flemish bond, English bond, and there are actually many other bonds. My team members and I were instructed to build a wall using bricks and mortar. So you can see the bricks and mortar, and we use tools like a spirit level, a steel square, a pail, a shovel, and a trowel. We managed to build the wall decently, and after the lecturer gave marks, we broke down the wall and kept all the materials and tools. So I think what I would like to share here is, of course, the building of the wall with practical workshop is something which not all civil engineers do. But what I would like to highlight here is something which I realized. I realized that it baffled me that the wall could be made in around half an hour, 45 minutes or less, and tore down just a few minutes after that. So that was quite confusing, because I expected the mortar to hold the bricks together. So I asked my lecturer, Mr. Buzzley, why can we break the wall so easily after that? So his answer was that normal mortar consists of ordinary Portland cement, sand, and water. But this mortar was different. It consisted of lime and fine sand. So what this means is that the mortar takes either too long to harden, or it will not harden at all. So we can tear down this wall very easily, and we can keep tearing down the walls. So of course this wall is not made permanently, it's just for the studies purpose. So this is something I would have never known if I had only learned theory. All right, next slide. All right, so this is some of my classmates' experience. This is Nurul Mashida Binti Anwar. At the beginning of semester 2, I was assigned to conduct a pavement engineering experiment in the highway laboratory. During the first 2 weeks, I did not understand the equipment, how to use the tools, or the purpose of the experiment. After receiving guidance and explanations, I became more familiar with the instruments and more confident in carrying out the experiment. I learned the functions of the tools and the importance of each test in pavement engineering. I realized that without this lab experience, I would not gain knowledge or understand the equipment and its purpose. The laboratory has helped me improve my skills and understanding of real engineering work. All right, next slide. All right, the last classmates experience. This is from Sanjana Devi. In my first semester, I learned a lot in the workshop. I became familiar with machines and the names of tools commonly used by civil engineering students for their projects. I also learned the lab protocols we must follow to stay safe. We use tools like the jigsaw, circular saw, and others during the lab sessions. I also learned how to write lab reports, which felt similar to preparing reports in a real job, and we submitted them before the deadline. The most important lesson was safety. We must be careful when using machines or tools that could be dangerous, and always wear safety jackets in the lab to protect ourselves and others. All right, next slide. All right, so the future directions in engineering workshops. So so I'm just going to share with you a little bit. So digital fabrication labs. So what does this mean? So I'll explain for ASEAN. So in ASEAN, new polytechnics and universities will start with 3D printers and CNC machines and laser cutters. I'll and also SMEs, small and medium enterprises. Small and medium enterprises collaborate with capital.
The participants play. Okay, you may continue, sir.
All right, thank you. So small and medium enterprises collaborate with campuses to prototype low-cost products locally instead of importing. All right, smart workshop and industry 4.0 integration. Um, all right, so students learn to operate PLC systems as well as robotic arms. This actually is seen in the Thailand automotive industry, in their factories and so on. All right. Virtual and augmented reality in technical training. I think the augmented reality part is, for example, for those of you who know the VR virtual reality glasses, which you put on your eyes. Yeah, that's what they use for. I think to simulate heavy machinery operation, and it reduces material waste and training accidents. It's useful for remote or rural institutions with limited equipment. Lastly, sustainability in engineering practice, especially I think going together with United Nations of SDGs, Sustainable Development Goals. So I think this is probably what they meant when it said sustainability in engineering practice, how to make buildings greener, more environmental friendly, and can last longer. I think ASEAN, for example, faces climate challenges like flooding, heat, and also haze. So we have a growing emphasis on ESG standards. All right. Next slide. All right. This is just my appreciation for everybody. You can read this, and that's about it. All right. All right. Thank you. Thank you. All right. Thank you. Thank you.
Okay, thank you so much, Mr. Abraham, for your great presentations. So yeah, I can see that the like practical is also very important, right? Besides the theoretical, and the internship program is very important to the students also, especially to the engineering students. Thank you so much once
Yep.
again. Okay, so I would like to share my screen first. Okay, please wait for a second. Okay, so let's wait. Okay, next we move to the next session, which is the Q&A sessions. So I would like to remind all of the participants, if you guys have any questions, you can just write down on the chat box, or you can also ask directly to all the speakers here. You can just turn on your audio and ask him directly. Okay, so since I already saw a lot of questions here from the chat box, I will start to read it first. Okay, so for the first questions, I think it's for Russia team. Okay, so from there's a question from Brevda. I would like to ask for previous team, for Russia team, based on your experiences, how does the combination of theoretical learning and internships help students better understanding real-world challenge in railway automation and tele, telemechanics? And she also curious about what do you guys think will be the most important skills, both technical and soft skill, should develop to succeed in the field of railway automation and telemechanics. Okay, so for Russia team, are you guys ready to answer the questions? Or you can just open your camera and also open your audio to answer the questions directly, please.
According to our experience, theoretical bus in combination with practical training helps you to be prepared for solving.
Okay, sorry. I think
Different tasks in real life, we are ready to professional activity. We should be ready to find an information quickly and analyze and use it, and of course we aim to see all the errors of problems with the railway equipment and be ready to correct them, including for work with hands.
Okay, thank you so much. Oh, is it already included with the second questions? So for the second questions, what do you guys think about what would be the most important skills?
We have answered both questions just at once.
Okay. Thank you so much for your presentations. I hope it's answering your questions, Rifda. You can answer it through the chat box so that we could know is it already answered or not. Okay. Thank you so much for Russia team. I would like to go to the next questions. Wait. Okay, so there is another questions from Hannah. Such an insightful presentation from Mr. Abraham. What do you think will be the most effective ways universities can improve student confidence and skills in practical environments, both in laboratory or company? So yeah, for Mr. Abraham, you can just answer it directly.
All right. The question is in the chat, right?
Yes,
It's in the
from
chat.
Hannah.
All right. From
From
Hannah.
yes, Hannah. Correct.
All right. Okay. All right. What do you think would be the most effective ways universities can improve students' confidence and skills in practical environments? Well, we can look at it in a few ways. I guess in Asia, or at least in Southeast Asia, one of the ways that you improve the skills is by having good lecturers. Of course, one thing is to have educated lecturers with maybe masters and PhDs and so on. But I think it's more important to have lecturers who have had on-site experience. For example, most of my lecturers actually worked in real site experiences and engineering companies before joining my college. So they were able to teach us quite well on the skills. Regarding confidence, I think it's all about practice, and it's a teamwork progress. You need to you need to you need to have a you need to have a
Okay, sorry.
you need to have a good you need to have a good team. When it comes to confidence, you need to have a good team. You need to have friends and classmates who are supportive to help you, especially when you yourself don't know a lot. Okay, regarding the so that's the laboratory. Regarding the company part, I think, for example, in my college we have an internship which goes on for 6 months. The 6 months internship is very helpful. It teaches you how to work, how to work in a real life experience, and how you look at problems in a working environment. Yeah, that's all. So yeah.
Okay, thank you so much, Mr. Abraham, for answering the questions. Okay, so for Miss Hannah, I hope it's answering your questions, or if you have follow up like next questions or another question, you can just put your questions on the chat box. Thank you so much, Mr. Abraham. Okay, next, I think there is another questions from Shafira, but I think for now, I will try to ask the Russia team first. Okay, so the question is from Shafira. Thank you for the insightful presentation for Russia team. I would like to know your guys' opinion on how will the integration of information technologies like ERP, MES, and SCADA evolve in the future of an industry 4.0, especially in developing countries. Thank you. And I think she have another question, but you can just answer this question first. Wait. Oh, there's another questions. And with increasing automation through through CNC machines and digital systems, how can industries ensure that human workers remain relevant and effectively involved in the process? Oh, so Shafira, I have like two questions for the Russia team. Okay, so for Russia team, you may answer the questions.
Well, we are sorry, the internet is unstable in our country now. If you don't mind, we will write the answer in the chat box.
Oh, yeah, okay, sure. Okay, thank you so much for Russian team. Yeah, you can just answer the questions on the chat box for Shafira. So for Shafira, you may wait for the answer for Russia team first. And then for the next questions, it's for Mr. Abraham. Please kindly wait. Okay, so the question is also from Shafira. So thank you as well for Mr. Abraham for your presentation as well as sharing your experience. I have two questions regarding your topics. So for the first questions, how does the combination of hands-on and minds-on learning help students develop essential 21st century skills like problem solving, innovation, and collaborations? And for the second questions, what strategies can students use to improve their technical adaptability through hands-on and minds-on experiences in engineering educations? Yeah, you may answer it. Thank you.
All right. Let me just read it from the chat. Okay. This is from GS. Oh, wait,
Yeah.
this is from
It is from Shafira. You may see it.
it's two questions, right?
Yes, exactly.
All right. GS of Shafira. All right. So, okay, regarding 21st century skills like problem solving, innovation, and collaboration, I think it's very important to note that when you're doing this hands-on, minds-on learning, you put into practice what you learn in the theory class. So what happens is that it teaches you more than just theory. It teaches you the problem solving of it in real life situations. And the innovation part, I think how it helps students is, for example, in my college, in terms of innovation, we have what we call FYP. I think most universities and colleges have that, which is the final year project. So final year project will include students having to maybe create or invent or maybe even innovate, making an innovation or for a new technology or a new idea in the field of engineering. So yeah, that hands-on and minds-on thing, whereby before we do the FYP, we actually do a bit of lab work as well. And collaboration, I think it's very simple. It's when you work in labs and also in workshops, it's rare to do it alone. When you're a student, most times you do it with other students as well. So that's where the collaboration works. Okay. Second question: what strategies can students use to improve their technical adaptability through hands-on and minds-on experiences in engineering education? All right. Okay, I think what strategies, I think, for example, one very simple one would be to focus during your lab work and also workshops. Focus on what the lecturer is teaching you, the materials used, maybe for other engineers, the machineries used, how to use the engine, how to use the machineries. I think it's important to focus. I think another way that you can improve your technical adaptability is, of course, one idea I had is when you have your semester breaks, maybe it's 2 weeks, 1 month, you can always go for a small internship or just a learning experience to some of these companies, like, for example, civil engineering, contractors, property developers, and so on. You can go and just learn with them to see, what they do, how they do, and that kind of thing. So, yeah, that's how you improve your technical adaptability.
Okay, thank you so much, Mr. Abraham. So it shows that internship program is really important, yes, sir. And also to focus, to focus on class or maybe or the when you do the practical on the laboratory and so on. Thank you so much, Mr. Abraham. Maybe for the last questions, we still have a little bit time. Okay, so for the last questions, I think it's coming from. Wait for a second. Yeah, I think it from coming from Rivda. So thank you, Mr. Abraham, for your presentations. I would like to ask about your opinion on how important is hands-on workshop experience in bridging the gap between theoretical knowledge and real-world engineering practice. Yeah, I think it's kind of similar. Okay, you may answer the questions.
All right. Uh, Okay. Bridging, how important is hands-on workshop experience in bridging the gap between theoretical knowledge and real-world engineering practice? All right. Regarding this, I would just give us a very easy example. For example, when my first semester for engineering, we use this AutoCAD. I'm sure most engineering students will learn about this AutoCAD, or I think there's another app called Revit or Revit, something like that. So that app actually designs buildings and also and many other things as well, machinery, equipment, and so on. So regarding the bridging part is when you design it using your computer or laptop, and when you actually do it in real life, you realize there are certain things which you miss when using the computer. So that way, when you learn your workshop, you actually your hands-on experience, you actually learn that. For example, a very good example is when you design a bathroom, for example, in Malaysia. In Malaysia, when you design a restroom, and I think most countries as well, you realize that the floor or the ground level of the restroom is actually lower than the normal floor level. That's because for sanitary and cleaning purposes lah. So purposes. So that's how you that's what I would say that's how you realize that it's not just all about designing. You also have to look at it in a different perspective. So yeah.
I see. So it's so interesting. Oh, to Mr. Abraham, could you also like write down your like recommendations for apps, like the one that you mentioned before? Perhaps, yes.
All right. I'll do that. We'll do that.
Yeah. Okay. Thank you so much, Mr. Abraham. Okay, so I think that's all for the Q&A sessions since it's already 4:52. Okay, so I think Shafra, you may check the chat box. The Russia team already answer your questions. Thank you so much for Russia team for the answer. Okay. Once again, thank you so much for Russia team and also Mr. Abraham for your great presentations and also answering all the questions. Okay, we go to the next sessions, which is the second sessions. So we will have another presentations from Capiz State University, the Philippines, and also from Institut Teknologi Nasional Bandung, ITNS, Indonesia. Okay, so for the first sessions, it's coming from students from Capiz State University, the Philippines. We will have Mr. Fahad Angoling and also Mr. James Ivan Abalana. Okay, so are you guys already here with us? Can you guys say hi?
Hello, ma'am. Good afternoon.
Good afternoon.
Okay, so
Okay,
I'll just share my screen.
yeah, sure. I will stop my screen first. Okay, I would like to remind all the participants, if you guys have any questions, you may write down on the chat box. And also, if you want to ask directly to the speakers, you can just turn on your audio. Okay, so the time and screen is yours. Thank you so much.
Okay, so is my screen visible already, ma'am?
Wait a second. This I can see the PPT clearly, but wait,
Here it is, ma'am.
I cannot see the. Oh yeah. I can see it clearly now.
Okay. Okay, so hello everyone. Thank you for having me today. Before I go with the talk, I would like first to introduce myself. I am James Ivan A. Balana, a civil engineering student, and most of
James,
my
I'm sorry to interrupt you.
yes, ma'am.
Your screen, I mean, like at first it's showing your title, but
Yeah,
now
yes, ma'am. Yes, ma'am.
it's blank.
Yeah, here, ma'am.
Yes.
My first slide is blank, ma'am, actually.
Okay. Thank you so much. Sorry.
Okay. Okay, so again, my practical experiences so far comes from my on-the-job training last year. And before that, my understanding of engineering was mostly based on concepts, lectures, textbooks, and design codes like the National Structural Code of the Philippines here in our country. So let us now proceed with the session proper. Okay, so I would like to start this talk with a question. Do you believe formulas alone can make you an engineer? Well, this is not to undermine the importance of studying but just to reinforce it with actual circumstances that are as equally crucial than the topics we learned in school. For years of studying, I thought I already understood engineering. I could solve differential equations, I could compute loadings, I could design different structural members like the beams and the columns, and of course, using a provision of the National Structural Code in our country. On paper, I was confident. But the first time I stood on a real construction site during my on-the-job training, surrounded by unfinished columns, exposed reinforcement bars, workers waiting for instruction, I realized something uncomfortable. I knew the formulas, but I didn't fully understand engineering yet. We have to understand that when we solve at class, what's at stake? Probably good grades, right? But when an engineer makes a mistake in real life, what's at stake? Safety, number one. We could endanger the lives of the people occupying or near our structure. And of course, money. When we analyze and design building incorrectly, the tendency is that we could not have a structure that would meet the standard, and with this, the structure itself will be prone to damages that will put financial burden to our clients. As students, we spend years preparing for our professions. We study theories, memorize standards, and pass exams. But there's a gap that many young professionals experience, the gap between knowing and understanding. As a civil engineering student, I lived in that gap for quite some time. So I have prepared different aspects, and we're in the engineering is quite different in terms of theory and application, and we will differentiate it as we go through with our discussion. First is in terms of focus. In classroom or in a classroom-based learning in engineering, it is usually all about abstract concepts, formulas, and models. If you get to analyze the problem correctly, you can generate a precise free body diagram, formulate the equation, and eventually arrive at a correct answer. It is that simple. However, Comparing it to actual site, it requires practical application, favorable site conditions, and of course, problem solving. For example, in our quantity surveying class where we learn to estimate cost of materials and labors in Tileworks, most specifically, we usually assume the total area divided with just the area of a single tile, and boom, we already have the number of tiles we need for our flooring, yeah. After that, we usually go on with the computation of its cost. However, one thing that was imparted to me by my mentor during my training is that we should have allowances in estimating materials. For example, in installing tiles, it is not completely guaranteed that our labors will not break a single tile. It's a good thing if they don't, but it's not also it's not bad if we have contingency plans or the plan Bs if and only if they are able to break some pieces of tiles. Through this, I was able to understand that in estimation, it is not bad to oversee unexpected situations, especially that this particular aspect is somehow affiliated with money. Later on, if we committed a mistake in estimating, we future engineers will be at fault, not our clients, and definitely not our workers. Next is in terms of problem solving. In school, the approach in solving problem is usually one way. We analyze the problem and then solve it. However, in site, there are usually unforeseen events that might need our engineering judgment. For example, here in the Philippines, we sometimes mix our concrete not in the actual site. We just carry them with concrete mixers, and the time of travel is usually computed from the mixing area up to the construction site. However, some delays like traffic are inevitable. These delays might affect the quality and workability of our mixtures as the concrete might start to harden or stiffen. As a future engineer, our engineering judgment is needed in these situations, given that delays are usually inevitable but pretty much unexpected. So in this instance, the common thing that we should just do is to add admixtures to our concrete to ensure workability. For me, instances like these really stretches our foundation of learning. That's why studying is very important. And of course, it challenges us to know how to apply our learning in our future site works. Okay, so next is in terms of collaboration. In theory, collaboration in engineering appears structured and straightforward, with clearly defined roles, organized discussions, and coordinated outputs. Plans are aligned and communication seems efficient on paper. In real life, especially on site, collaboration is more dynamic and challenging. Engineers must constantly coordinate with foremen, workers, suppliers, and other professionals under time pressure, reworks, and safety risks. I can still remember during my training, I could hear my boss talking to different project personnel from laborers to engineers and to the different project inspectors all day, from morning until afternoon. Unlike theoretical group work, real world engineering collaboration demands continuous dialogue, quick decision making, and of course, shared accountability to ensure project success. And lastly is, of course, the outcome. In theory, we usually arrive in a correct answer, while in sight, our outcome should be a functioning structure that must meet the codes, budget, and community needs. In school, I learned the foundation of engineering, solving equations, designing structures, and following codes. Those lessons will give us confidence. But it was only when we step into the real world or real construction site that we will get to understand their true weight. On site, every calculation meant safety, every estimate meant money, and every decision affected people. Theory shaped my mind, our minds, but practice shaped our heart. And together, they gave us a deeper, more personal understanding of engineering. So to end my talk, I want to instill this phrase to all of you. Practical experiences teaches you that theory is the foundation, but application is the structure. With this, we can finally say that we understand engineering by heart and by soul. I hope I have imparted something in your brilliant minds, and just always remember that while we learn in our four-cornered classrooms, it's also a great exercise of knowledge to have practical experiences regarding our chosen field of work outside the school. I hope to see you inside Future Engineers. At this point, I will now pass the floor to my co-presenter, Fahad Anggoling.
So good day everyone. As first before I present, if am I audible? Am I audible?
Yeah, we
Thank
can
you
hear
so
it.
much. So good day everyone. My name is Fahad Obligarang Guling, and today I want to begin my session by simply with the thought that once kept me awake at night. Am I truly becoming an engineer, or am I simply learning how to pass? Maybe some of you have felt that too. You attend lectures, you copy notes, you solve problems step by step, you review before exams, you pass. But deep inside, there's still the small voice asking, do I really understand this? Can I actually apply this in real life? Am I really for the responsibility of the professions requires? Because engineering is not just about getting the correct answers. One day, we all know that things we design may carry people's lives. One day, the structures that we build may protect families. And one day, our decisions will matter beyond the classrooms. And that realization can feel overwhelming. For me, everything changed when I step up into the workshop, or for example, the on-the-job training. That was the very moment engineering stopped being just formula on papers and started becoming something real. That experience didn't just improve my understanding, it strengthened my confidence. Today, I want to share how practical workshop helped me move for simply passing to truly becoming. And now, let's begin the day engineering become real. Next slide. So before the workshop, as we all know that there is always confusion, there is always doubt, and there is always pressure. Before practical workshop, we all know that we are just only surviving engineering, not living it. We memorize formula, we solve problems, we pass quizzes, but deep inside, we was unsure. I understood the theory, but I couldn't find it. Engineering felt like something distant, not something that we could carry through become. So before I step up into the workshop, I remember that those days that holding the tools for the first time, feeling the weight of the materials, seeing the structures not in the diagrams, but in front of me. And suddenly, the formulas had meaning. The stress and the strain that we studied, I could see it, I could observe it, and I could understand it. And that was the moment everything changed. Next slide. So as you can see in the presentation, it states every measurement matters, every detail counts. So as we all know that in the workshop, I realized something that there is power, or realize something that is powerful. A small mistake is not just a wrong answer. It can mean instability. About protecting lives. Every measurement matters, every detail counts, and that realization will make us grow up, not just a student, but as a future engineer. Next slide, please. From doubt, there is always confidence. There was a shift inside me, or then the student, once who doubted himself, started believing. Because not just only reading about engineering more, we are doing it. Testing, adjusting, and learning. We know that we made mistakes, but we improved. And with every completion, our confidence grows stronger. Next slide. So in the slide, it was already stated, engineering is not just a degree, it is a responsibility. So I realized that engineering is not just a course, it is, or not just a profession, it is a responsibility. One day, the things that we design could hold on family safe. One day, the structures we helped build could stand for decades. Workshops made or will make us see the impact of what we are studying today. And for the first time, I felt proud to call myself an engineering student with the help of practical workshop. Next slide, please. Engineering is not just learning, it is experience. Practical workshop didn't just help us understand
Sorry,
engineering. They would be able to help us believe in ourselves. They turn fear into strength and confusion into clarity. So also, next slide, please. And
Okay.
also, lastly, I would want to end my presentation by just simply stating that we are not just only studying engineering to pass, but we are studying to build, to create, to serve. That is the power of practical learning. So before, I would like to end a powerful quotation to you all that when you doubt yourself, remember, bridges don't stand on confidence, they stand on position. Thank you for listening to our talk today.
Wow, thank you so much, Mr. James, and also Mr. Fahad, for your great presentations. Really cool. I like the words that you mentioned before. It's not just a degree, but it's also a responsibility. It's really cool. Thank you so much. Okay, without any further ado, I will go to the next session. Wait. Okay, wait a second. Okay, once again, thank you so much, Mr. Fahad and Mr. James from Capital State University in the Philippines. We will go to the next session. We will have another speakers from Institut Teknologi Nasional Bandung, ITENAS, Indonesia. And it's coming from Mr. Amil Abinanda Mulyanegara. So for Mr. Amil, are you already here with us?
Yes, I am here in the Zoom meeting.
Yeah, okay. Thank you so much, Mr. Amil. Okay, I will help you to share your screen, please. Kindly wait. Okay, can you see my screen now?
Yes, I can see my screen.
Okay. So the time and screen is yours,
Okay.
Mr. Amil.
Hello, everyone. My name is Amil Abinandana Mulyanegara. I am an undergraduate student of mechanical engineering here in ITENAS. Today, I'm going to present you my presentation about internship experience as an engineering student. Next slide, please. Okay, first of all, the background of an internship. Why did I apply for an internship as an engineering scholar? First of all, it connects classroom theory with real engineering practice, develops hands-on technical problems and problem-solving skills, exposes students to real industrial systems and workflows, build professional skills, teamwork, communication, and discipline, prepare students for real-life engineering careers, and lastly, to convert college credit. Next slide, please. So the main purpose of an engineering internship is apply engineering to real industrial practice, understand production processes and mechanical systems, develop technical skills such as assembly, maintenance, and design, strengthen soft skills as teamwork, communication, discipline, improve technical analysis and problem-solving skills, And also the most important part, gaining more friends and important connections for the near future. Next slide. Okay, the place where I took this internship is PT Land Industry, where it's an Indonesian state-owned enterprise established in 1991, operating in an electronics industry. The company develops, produces electronic systems for industrial, transportation, and defense sectors. That is a short description of the company. Okay, next. The work division that I work in, I work as the Project Development Deployment Center, or PDC division. It focuses on project execution and implementation for its teams, vendors, and clients, responsible for installation, testing, and project handover. And lastly, to conduct and monitoring and prepare progress reports. Next slide. My position as an intern in that work division is a project assistant position where I assist with project administration and documentation, prepare reports and meeting minutes, support coordination between teams, gains hands-on experience in project implementation processes. Next. The main project that I worked in that company is the electric bike sprint at PT Land, which is a proud product of the company. Next. Internship activities. Now we are going to the part where there are a lot of activities that I've done through this internship that actually involves more than just mechanical engineering. It goes through than that. I learned more things besides all the things I learned in college here. Let's go on to the next slide. Administration work. Even though I'm a student at mechanical engineering, I learn a lot of things in the offices like administration work, where I learned to make a few documents about paperwork and also a few schedules on upcoming production processes. Next slide. This is an example of what I've created in that division, which is a main component quality checklist form, which is in the aftermarket service. Next. Electric motorcycle maintenance. This is where I apply a few of my class theories to real-life application. Next. Logistic preparation. This is where we prepare a few of the products to be transported around the company and to other clients and to other expos. Next. Testing and monitoring. This is where we conduct tests of the product if that product that comes out of the assembly line is up to quality. Next. In conclusion, an internship for an engineering student is not just a graduation requirement, but a transformative journey that turns knowledge into real impact, shapes professional character, and inspires the confidence to become a future engineer who is ready to innovate, solve real-life problems, and contribute meaningfully to society. Thank you for your attention. This is where my meeting ends.
Okay, thank you so much for Mr. Amil for your great presentations. I think we still have more time to do the Q&A sessions. Thank you once again, Mr. Amil. I will try to share my screen first. Okay, please kindly wait. Okay, so our next session will be Q&A sessions for Philippines team and also Indonesian team. Okay, so for all the participants, if you have any questions, you may write down your questions on the chat box, or you can also ask directly to the speakers here if you want. Sure. Okay, since I have some questions already on the chat box, I will try to ask the questions to the perhaps for Philippines team first. Okay. Wait. Okay, so from Emily S, her questions is I want to ask to Fahad and Mr. James, how can students better prepare themselves to handle unpredictable situations in real engineering environments where conditions don't match assumptions? Okay, so to Mr. James and Mr. Fahad, you may answer the questions.
Okay. So to answer Miss Emily, how can students better prepare themselves to handle unpredictable situations in real engineering environments where conditions don't usually match assumptions? So as for me, it is where experience comes into a clutch. When you're an experienced engineer, you are going to you'll know the possibilities when you're constructing a particular structure, and then you're going to know the risks and the possible drawbacks and disadvantages when you are doing a particular project and a particular strategy. So I think that's why we really need to have an experience, even though it's not that much. It's very important to have at least a basic training, because we all know theory in classroom is really different. It's far different if we're going to compare it on site. That's just for me.
May I add?
Yeah, sure. You can add Mr. Fahad. Okay. Do you have anything to add from Mr. James' answer?
Okay, sorry for the slow internet connectivity. So my answer would be students can prepare for unpredictable situation by developing three things. That would be adaptability, critical thinking, and a strong foundation in a theory. Because I think that in real engineering, conditions may rarely match assumption. So it's important to not only know the basic formulas, but also understand why they work. So students, of course, should practice analyzing problems from multiple angles, asking what if questions. So, and learning to make decisions in under pressure by combining knowledge, carefully observation, and mindset of responsibility. They can face uncertainty with confidence and ensure their work is both safe and effective. So, three things: only adaptability, critical thinking, and a strong foundation in a theory.
Okay, thank you so much, Mr. Fahad. So I can conclude that actually, like basically the theoretical and also the practical is balance should be balanced one another, right? Okay, thank you so much for the answer. I hope it's answering your questions, Emily. Okay, I will go to the next questions. I think for Mr. Amil first. Okay, so for Mr. Amil, it's also from okay, I think from Rivda first. So, Mr. Amil, glad to have you join with us. Thank you for such an insightful presentations. I would like to ask about what were the most valuable technical or soft skills you developed during your internship as a project assistant.
Okay, my answer for that, my most favorite skill that I learned from that internship is the ability to find solutions in other facilities, because I was given a lot of tasks that I didn't know anything about, but the company and other supervisors gave me a lot of access to many websites or even many books about how to overcome the solutions. Now I know where to get the answers that I needed. When do I need it?
Ah, okay. Okay, thank you so much, Mr. Amil. So hopefully it's answering your questions, Rifda. Okay, so for the next questions, next for Mr. Amil, first. Okay, so it's the question is from Emily. So I want to ask, based on your experience, what are the biggest challenge you met while working on a real project at Thailand industry, and how did you overcome them? Any tips? Do you have any tips? Yeah, you may share
Biggest
your story.
obstacle is uh, in that internship, if you do something wrong, even as an intern, the workers will still be mad at you like you are a worker. So the biggest challenge for me is facing a lot of anger from other workers if I did something wrong, because they don't see you as an intern. They really see you as a real life worker because you came there to train on the job training. To overcome that, I decided to talk it out with a few of my friends who are joining the internship, and also talking to a few workers who are actually kind-hearted enough to open up and say like, yeah, they treat you like this because they want you to be strong here. They know that you came here to know how the real world works. So yeah, that's how they are gonna treat you. For tips, maybe don't take a lot of things heavy-hearted. Even though they're mad at you, don't forget you made a mistake. It's okay, but that doesn't mean you should quit or give up, because that's how the real world works. I guess that's it.
Okay, thank you so much, Mr. Amil. So just don't take it too personally, yeah, when you perhaps with
Yeah.
yeah. Okay, thank you so much, Mr. Amil, for your tips and also your stories. I hope it's answering your questions, Emily. So yeah, just don't take it too personally when you are jumping to the real situations later. Okay, next, I think questions for Philippines team, for Mr. James and also Mr. Fahad. So the questions from Shafira. The first question is how does wait a second. How does the strict enforcement of safety in real world settings change the way engineers think and work compared to classroom discussions? And for the second questions, and what mindset should students develop to understand that in real engineering, every measurement and detail truly matters? I think that's the questions. You may answer the questions.
Okay. So, strict enforcement of safety in real-world settings fundamentally changes how engineers think, decide, and of course act compared to classroom discussions. In classroom, safety is often presented as formulas. We have also load combinations, factors of safety, and of course the codes and provisions. Problems are structured. We can say that it is structured. Assumptions are given, and consequences are theoretical. A wrong answer might mean just a lower grade, right? However, in real engineering or real world engineering, safety becomes personal, legal, and of course, ethical. Engineers must think beyond calculations and consider uncertainty and human behavior, of course, workmanship errors, material deflects, and unforeseen site conditions. So they become more conservative in judgment, more meticulous even in documentation, and more collaborative in decision making. And for the second question is what mindset, right? In real engineering, student must develop, I think, a mindset that values both precision and responsibility, because we all know every measurement, calculation, and detail matters because they affect real structures and, of course, the real people. So that's just for me again.
So to
Okay,
add
thank
for,
yeah. You may add.
I would also add for the second question about the mindset of what students should develop to understand that in a real engineering, so every measurement and detail truly matters. So for me, in real engineering, every measurement and detail truly matters, and it depends really on them. So as a student or as the future builders of tomorrow, we must develop a mindset of responsibility and care. That instead of asking, will this building pass? Why not? We should ask or start asking, what happens if this building will fail? By imagining a real people relying on a work, we learn to be precision or to be precise, thoughtful, and disciplined. So true engineers understand that even the smallest detail carries weight. And that mindset is what turns knowledge into safety, trust, and impact. So we should always ask if this, what will be going to happen if this building will going to fail.
Okay. Thank you so much for your answer, Mr. Fahad and also Mr. Jens. So I hope it's answering your question, Shafira. Actually, we still have like some questions here, but unfortunately, the time for Q&A session 2 is running out. So I think I'm just going to wrap up the sessions. Thank you so much once again for Mr. Amil, Mr. Fahad, and also Mr. James for your great presentations. Okay. So for the participants, maybe hopefully we can meet again on another time to ask another speaker later. Okay, we may go to the next sessions, which is the group photo. So I would like to remind to all participants to open your camera and also don't forget to use our virtual background that already provided and can be downloaded on the chat box. Yep, I will stop my screen first and I will wait for about a minute, I guess, to wait for all participants to open their camera. Okay. Wow. Now we have around 254 participants. Wow. That's we have many. Okay, guys, don't forget to also use our filter background. And also, don't forget to follow our social media. We have social media too. On Instagram, it's called pasita.education. So my college will also put the account name on the chat box. We will share our activities on the Pasita Education account Instagram. So, and to all speakers, if you want to be mentioned on the story letter, you may also reply a story letter. Okay. Okay. And also the attendance link will also be shared after the sessions. Okay, please kindly wait. Okay, I saw a lot of people here now. Okay, I'm going to count. Wait. Okay, 1, 2, 3, smile. Okay. Okay. Wait. Okay, next for the second slide. 1, 2, 3, smile. Okay. Okay, guys. Once again, I would like to say thank you so much for all the participants here for joining our events. And also thank you so much for all the speakers from Russian team, Philippines team, Malaysia team, and also Indonesian team. We guys truly such a pleasure to have you guys here with us today. And see you on another event. Thank you so much. And for all the speakers, you guys will have the certificates later. My college will give you the certificates after the sessions ends. Thank you so much. And to all participants, don't forget to fill out the attendance link. It's already provided and you may check on the chat box. Thank you so much. See you guys. Thank you so much for having us.